So natural numbers are numbers used to count objects or things. Okay, so the way I think about natural numbers is just every number after 0 is a natural number. So 1, 2, 3, 4, 5, on and on and on and on. Those are natural numbers. Then, okay. Whole numbers are including 0, so 0 and on. Integers are all whole numbers, so negative and non-negative whole numbers. Rational numbers are like any number, including rational numbers, like fractions that aren't, so like numbers that aren't whole numbers are included in rational numbers. Then irrational numbers are numbers that go on and on and on and on. They have repeat, they don't, and so like pi would be an irrational number. And so yeah, here. Oh, this Venn diagram is really helpful. So natural numbers are like all of the above, and irrational numbers are their own thing.
Yeah.
So if we go back to this little, like I would always refer back to this, right? So if you have a rational number, it can, in most cases, money is a different issue because money can't be negative. But in most cases, whenever you have a rational number, it's also an integer, a whole number, and a natural number. So like if you have a rational number, it's also all the stuff in the little circles. And if you have an integer, it's the stuff inside the integer bubble too. Finding intersections and unions of sets. Find a this is A intersection with B and A union with B. So, okay. So in this one, you're finding the intersection. No, sorry. Yeah. So here you're finding the intersection. So the intersection is basically which numbers both of these sets both have. So in A, you have a 6, and in B, you have a 6, and then in A, you have a 12, and in B, you have a 12. So that would be the intersection, 6 and 12, because they both have it. And then the union would be just combining the two. And the way I kind of like remember it when I forget which one's union, which one's intersection, the one union is shaped like a U here. So that always just like reminds me, okay, that one's union, and that other one is intersection. Okay, describe the following events as impossible, unlikely, as likely as not, likely, or certain. All right. Gavin rolls an even number on a number cube. What would you classify that as?
As likely as not.
Good. The first person that Sonia meets is a left-handed person.
Unlikely.
Yeah, I'd say that's unlikely.
Wait, it means the first person.
I'm guessing like if she's in a crowd, the first person that she talks to is left-handed. I think that's what they mean.
Person that Sonia means is like different likely than right-handed.
It's unlikely.
Wait, but then is a left-hander more unlikely than right?
Yeah. What is the probability of landing on A, on B, on C? Express each probability as a fraction and as a percent. All right. So for the probability of landing on A, what do you think the fraction would be if you had to express it as a fraction?
For E?
For A, for outcome A.
Wait, A?
Do you see the table?
Oh, the outcome. I thought you were talking about the question.
Oh yeah, question E. It's asking for the probability of landing on A. Do you know how to calculate probability, or?
Yeah, I do.
Okay.
Landing on A. 1 out of 3, 1 out of 3, and 1 out of 3.
Yeah. Well, it's part over whole. So the probability of landing on A, so A shows up 9 times. 9 out of what? If you do 9 plus 6 plus 10, you get 25. That's how many times she spun the spinner in total. So
But
for
wouldn't that be the outcome of the events more than like the probability?
yeah, so 25 is the outcome. So it's the number of times she spun the game spinner in
So
total.
9 out of 25, 9 out of 25. Oh, 9 out of 25, 6 out of 25, and 10 out of 25.
Yeah.
But then we would need to add as a percent.
And then for percent, you just do like on a calculator, you do
So it'd be 36% for A,
you just
and
like
it would be 24% for AB, and then it would be 40% for C.
yep.
Okay.
Yeah, perfect. All right. So for F, predict which letter will Jamie most likely spin. Explain your reasoning. Okay. So if you look at the probabilities that you did for question E, look at the percentages. Which one had the highest percent of getting chosen? And that's probably the one that you want to pick because since it had the biggest percentage, it was the one that was chosen the most often. So it's probably your best bet.
It would be C because it has the most frequency out of all the A frequencies.
Yep.
So it would be the highest probability of
Yep.
getting the C.
Yep, perfect. Exactly what I would put.